a continent almost as large as Europe, covered by an ice shell more than 3 kilometers thick. From the outside, it seems still, silent, immutable. But beneath that ice, Antarctica is not a dead desert. It is a hidden world. And what happens down there can change everyone's life, even thousands of kilometers away. Because Antarctica is not just ice. It is flowing water, buried mountains, dark lakes, rivers under pressure, hot rocks, microorganisms that survive where no human being could live. It is also a kind of planetary archive, a place that preserves the past and, at the same time, can decide the future. Let's start with a simple point. Antarctica is divided into 2 large zones. East Antarctica is higher, colder, and generally more stable. West Antarctica, however, is different. It rests partly on rock that lies below sea level. It is as if it were a large basin covered in ice. And when the ocean enters beneath the ice, it can melt it from below. And when a glacier begins to lose ground in that area, it can accelerate. And here's the first reason why the world could change beneath Antarctica. Sea levels. Many people think the ice only melts above due to warmer air. But in Antarctica, the problem is often below. Relatively warmer ocean water can seep under the ice shelves, those enormous shelves that float in the sea and hold back the glaciers inland. If these shelves thin or break, the glaciers behind them flow faster toward the ocean. It's like removing a plug or a brake. When the ice ends up in the sea and melts, the sea level rises. Even a few decimeters change the coastline, increase storm surges, make flooding in low-lying cities more frequent, ruin ports, roads, and sewer systems. It's not something far away. It's something that affects the economy, insurance, homes, and infrastructure. It affects millions of people. But what does the subsoil have to do with it? It certainly does. Because beneath the ice, there's more than just cold rock. In some areas, there's heat. West Antarctica has areas of geological activity, like a sort of large system of fractures and rifts. This doesn't mean volcanoes exploding tomorrow, but it does mean that in certain places the base of the ice is receiving more heat from the ground. That heat can increase basal melting, that is, melting from below, and can create or feed liquid water beneath the ice. And here we enter the second hidden world, subglacial water. Under kilometers of ice, in many areas, water exists. Not because the environment is hot, but because the pressure is enormous and because there is heat coming from below, plus the friction of the moving ice. This water doesn't stay still. In some cases, it forms gigantic lakes. In others, it flows in channels and rivers. It's an invisible water system, like a network of veins beneath a body. One of the most famous examples is a large subglacial lake, discovered through radar and measurements, which is enormous in size. But the really important thing isn't the name of the lake. It's the idea. If there's water underneath, the ice slides better. It's like putting a film of water under a sled. This could accelerate glaciers toward the sea. So beneath Antarctica, there's a mechanism that can accelerate ice loss. And if it accelerates at a key point, it can trigger chain reactions. It's not magic, it's physics. And that's one of the reasons scientists study the base of glaciers so closely. But there's another side, even more disturbing and fascinating. If there are lakes isolated for millions of years, what lives there? In extreme conditions, without light, with very little nourishment, specialized microorganisms could exist. We're not talking about monsters, but microbial life capable of surviving in total darkness. This research is important for 2 reasons. The first is that it tells us how resilient life can be on Earth. The second is that it becomes a model for understanding where to look for life elsewhere, for example, beneath the ice of some moons in the solar system. So, beneath Antarctica, there could be a natural laboratory that helps us answer a huge question. Can life exist even where it seems impossible? And it doesn't end there. Beneath Antarctica, there's more than just water and microbes. There are also mountains. It seems absurd, but beneath that ice, there are buried mountain ranges. Some are very ancient, carved in a time when the climate was different and Antarctica was not the frozen continent we know today. These mountains influence the shape of the ice, the direction of its flows, and the speed of the glaciers. Essentially, they're like obstacles and channels that guide the ice without us seeing them. This changes how we predict the future. To understand how much and how the ice will move, we need to know what the terrain looks like underneath. If there's a deep valley underneath, the ice can flow like a river in a natural bed. If there's a ridge underneath, it can slow down. So the world map below is one of the keys to understanding tomorrow's sea levels. Many people ask me how I create video sequences when there's no real footage. In this project, I also used Kling AI to generate several clips. If you'd like to try it, you'll find the link in the description. And now we come to a crucial point. Antarctica isn't just a risk. It's also an archive. Inside the ice, there are layers that have accumulated year after year for hundreds of thousands of years. Each layer preserves traces of the past atmosphere, like trapped air bubbles. These bubbles are literally samples of ancient air. By analyzing them, scientists reconstruct how much CO2 there was, what the temperature was like, how climate cycles changed. This means that Antarctica allows us to understand what happens when the planet changes. And this knowledge isn't theoretical. It helps us build more accurate climate models, understand real risks, and make better choices. So, in a certain sense, beneath Antarctica lies a kind of memory of the world. And this memory is telling us something. The climate can change rapidly when certain balances are disrupted. Now, let's jump into the present. Because if Antarctica can change the world, it's not just for science, it's also for geopolitics. Antarctica is regulated by an international treaty that, very simply, limits militarization and manages research. It's a delicate balance. Today, Antarctica is difficult to exploit. It's expensive. It's remote. It's extreme. But as the world changes and technologies improve, the temptation to view that continent as a reserve grows. And here we must be clear. Today, talking about extraction and resources is more of a political and future issue than a large-scale practical reality. But the interest exists, and when an area becomes more accessible, interest increases. Then there's water. It seems paradoxical, but in a world with ever-increasing water stress, ice can become a dream resource. It's not easy to transport, it's not economical, and it's not an easy solution. But the very idea changes the tensions. Because when something is huge and precious, sooner or later someone will try to get close. And amid all this lies another dimension. Antarctica as a unique scientific platform. For example, it's one of the best places in the world to search for meteorites. The ice, as it moves, can concentrate space rocks in certain areas, and the white background makes them easier to find. Every meteorite is a message from the primitive solar system. Studying these rocks means understanding how the planets formed, where water comes from, how certain elements were distributed, and then there's the sky. Antarctica, with its dry, cold air, is an exceptional place for certain observations and special experiments. There are instruments that use ice as a means of detecting particles that are almost impossible to capture. This is advanced science, but with a concrete result: understanding the universe in order to understand ourselves, and improving technologies and measurement methods that will then be useful elsewhere. So, beneath Antarctica doesn't just mean beneath the ice. It also means beneath the surface of things, beneath what seems immobile. But let's return to the central question. How could the world really change in the coming years? The most direct point is the stability of the West Antarctic ice. If it loses mass faster than expected, sea levels could rise faster than many coasts have been ready to endure. This puts pressure on cities, ports, and economies. It increases internal migration, tensions, and enormous costs. The second point is that understanding what happens under the ice makes forecasts more accurate. And more accurate forecasts change decisions. Where to build, what to protect, how to design dams, how to plan insurance, how to manage emergencies. Science here is not just curiosity, it is a practical guide. The third point is that Antarctica is increasingly becoming a symbol, a test. If the world manages to protect it, it can also manage cooperation, rules, and limits. If, however, it becomes a competitive arena, then what happens there could foreshadow future conflicts over resources and extreme territories. And there is a final point, more subtle but important. Antarctica forces us to think big, because it shows us that the planet has parts that seem distant but are connected to everything else. Under that ice is a system that reacts to the ocean, to heat, to pressure, to changes in the atmosphere. It is a huge balance, but not infinite. Antarctica is not a distant place, it is a lever of the world. Beneath that continent, hidden in darkness and silence, lies a mechanism that can raise sea levels, reshape coastlines, change economies, shift political interests, reveal extreme life forms, preserve climate memory, and tell us where we're going. And perhaps this is precisely its strongest point. The continent that seems most stationary of all is one of those with the most potential for movement in the fate of the planet. We don't see it, but it's at work. Beneath Antarctica lies Earth's past, and it may also contain a part of our future.